working in the lab late one night, when my eyes beheld an eerie sight. For my monster from his slab began to rise, and suddenly, to my surprise, he did the monster. From my laboratory in the castle east, to the master bedroom and the vampire's feast, the ghouls all came from their humble abode to get a jolt from my electrode.
Welcome to Monster Math with Mrs. Lehman. I'm here with my 6th period class. So we have a Halloween joke today. Happy Halloween. It says, how many monsters are good at math? None, unless you count Dracula. How's that for a cringy joke, kids? All right. We're going to move on. All right. So, yesterday we started talking about finding the sum or difference of fractions and decimals. So, what does it mean to find the sum? What operation are we talking about, Riley?
Sum is adding.
Very good. And difference is?
Subtracting.
Very nice. All right. So, we looked at some denominators that make this really an easy task. All right. So, we have, for example, question A here, which we'll do together. So, we have 381 and 1/10. And we are subtracting 214 and 43 hundredths. Right? We want to turn these into decimals. So, how would I write 1/10 as a decimal? Cam?
1.
0.1, right? 0.1, yeah. So this first place past the decimal point is our tenths spot. So we are going to put 1/10 there. And then 43 hundredths. Hundredths. Where would that one go? What would we put? Cam just answered the last one. What do you think, Tori?
0.43.
Very good. 0.43. So we would just write that like this. What do I put behind this one up here? Stephanie? A 0, yeah. Have I changed the value of that number? No, not at all. All right, we're going to subtract. All right, can we take 3 from 0? No, we have to go next door. We have to borrow from this guy. Now that becomes 10 minus 3. 10 minus 3, everybody is? 7. Very good. 0 minus 4, can't do it. You got to go next door. Whoops, that's 0. 10 minus 4 is? 6. What do I have to do with my decimal point? Yep, pull it down, bring it down. Remember, these all have to line up. 0 minus 4, can't do it. Go to 8, turn it into a 7. 10 minus 4 is? 7 minus 1 is? 3 minus 2 is? 1. Any questions on that? All right. Okay, we're going to try a different example that's maybe a little more challenging. So let's try B. So everybody, let's stack this problem in a vertical format here. So we have 32 and 3/4 minus 12 and 1/2. Right? We are going to make these compatible with the denominators that have decimal places. All right? So we are looking to change that denominator of 4 into a 10, a 100, a 1000, etc., a power of 10. All right? So we're going to do that with 1/2 as well. So if I have 3/4, how could I scale that up to turn that into, well, 10 won't work. Could we make 4 into a 100? Yes, by multiplying by what? By 25, right? So 4 times 25 is 100. Do the same thing to this 3. 3 times 25 is 75. Have I changed the value of 3/4 by making it 75 hundredths? No, and that's why it's legal to do that. All right? The math police will not pull you over for doing that. We have 12 and 1/2. We could make that tenths, right? 2 times what gives us 10? Stephanie? Hold on, I'm coming over to Steph. 5, very good. And 1 times 5 is 5. All right, now we are going to bring it over and make it a decimal. So 32 and 75 hundredths, how would I write that? 32 point, Cassie?
75.
Very good, 0.75. And 12 and 5/10. How would I write that? 12.5. Very good, Aiden. All right, what should I do after this 5 right here? Put a 0, yep. We're going to subtract 5 minus 0 is 7 minus 5 is 2. Decimal point, 2 minus 2 is 3 minus 1 is 2. Very good. So we have 20, and how would I read that decimal? How would I read that whole number, actually, Christoph?
20.26. No, 25.
Right. Now, how would you read that technically, like a mathematician?
25.
And 25 what?
100.
Very good. 20 and 25 hundredths. All right. So, if you can take these these fractions that we started with, like 3/4 and 1/2, and scale them up so that they have a denominator that is a power of 10, then you can convert these into decimals very easily. Now, let's say you have a denominator of 8, for example, right? Can we scale that up to get it to be 10 or 100? No, that's going to be a pain, right? So, what can we always do to convert any fraction to a decimal? Any fraction to a decimal. Joe?
Simplify.
Nope, not simplify. Cam?
Divide.
Divide. What do you mean? Divide what by what?
Divide the numerator by the denominator.
Very good. And that will work 100% of the time, okay? So if we were to take 3 and divide it by 4, we would end up with 75 hundredths, right? If we took 1 and divided it by 2, we would end up with 5/10 or 50 hundredths, okay? So there is more than one way to get to that. This is just to kind of expand on that proportional understanding that you learned in Module 1 and take it to decimals, which is one of the primary focuses of Module 2. All right, today what we're going to do is actually go to the next page, which I kind of left some notes here from last class, which is Lesson 10, the distributive property and the product of decimals. We're actually going to be skipping a little bit of this distributive property stuff, and we're going to just focus on how do we find the product of decimals. So here's a really obvious question since it's written on the board. We know that sum means we do what operation? Add. Difference means? Product means? Multiply. Yep, so if you see this question, find the product of these two numbers, that means you need to multiply. All right, so on the top of your page, I would like you to write this down, all right? Here are the steps to multiply decimals. Step number 1, put the number with more digits on top, all right? So if it has more digits, put it on top when you multiply. That's just how it goes. That's just how it goes. So, for example, you would not do this, right? When you're multiplying, you wouldn't say 12 times 375, right? That would be a weird way to write that. You would want to flip the other way around. All right, the next step is multiply. So you're going to do all your normal multiplication. You're in 6th grade, so the assumption is that you know how to multiply already, and then you do the whole adding step and all of that. Your third step would be to count the decimal places in both factors. So you look at your problem, the two numbers you're multiplying, you're going to count up all of the numbers that are behind that decimal place, or decimal point, and then you're going to slide that many number of places in and put your decimal point there in the product. All right? All right, so we are going to practice a few of these. So if you look at the bottom of this page at the opening exercise, it says calculate the product. We have 200 times 32 and 6/10. So you have an option here. They both have 3 digits, right? So technically it doesn't matter which one we put on top or bottom, but there is one that we can put on the bottom that is going to make life a little bit easier. What one would be easier to put on bottom, Aiden?
200
Why 200?
because it's a smaller number.
Nope, that really, actually 32 is much smaller than 200, right? So that really has nothing to do with it. Michael?
200 goes on top because it's bigger than 32.
Nope. You guys are really thinking, like, how you typically would when you're dealing with whole numbers, right? So now we're dealing with numbers that may have a lot more digits, but actually has a much smaller value than another number that only has a digit or two, right? So, for example, we could have, 125 10,000. It's got a lot of digits, right? But that's still a lot smaller than 5, which is just one digit. So, why would it make sense to put that 200 on the bottom? So we have 32.6 times 200. It's just a little shortcut. Why is that quicker? Riley?
Because if you put it on the top, then you have to do 6 times 200, 2 times 200, 3 times 200. When if it's on the bottom, you can just add 2 zeros and then do 2 times 6, 2 times 2, 2 times 3.
Nice job, kids. All right, so we can just pull these zeros right down. All right. Otherwise, if you set it up the other way, yeah, you'll get to the same answer, the same product. But you'd have to go 6 times 0, 6 times 0, 6 times 2. Okay, placeholder 2 times 0, right? It's a lot of extra work. Ain't nobody got time for that. All right, so 2 times 6 is 12. So we're going to put our 2 down, carry our 1. 2 times 2 is 4. Oops, I forgot the plus 1. Oh, gosh. Reverse. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. All right, and notice I didn't put my decimal point in. So what you're doing now is you are looking at these two numbers, right? And you're saying, oh, look it. Here's one place past the decimal point. There is no decimal point here, so none of these numbers are going to count for that. So you're going to start back here, and you're going to take that decimal and use, hopefully it works, yep. So I'm going to move it in one spot. All right, so your answer is 6,520. You can put the comma there if you'd like. All right, why don't you guys go ahead and try number 2 on your own, okay? I am going to pause the video while the kids work, and then we'll come back to check. All right, we are going to set this up. So I have to decide what number I want to put on the bottom here. Obviously, there's a number that has more digits than the other one, right? So I have to put the 2.12, otherwise known as 22 and 12 tenths. Oh, it's been a long day. It's Halloween. 22 and 12 hundredths on top, and the 500 on the bottom. So raise your hand if you had that set up correctly. Perfect. All right. The little trick is I can just bring down these 2 zeros, right? 5 times 2, everybody? 10. Carry your 1. 5 times 1 is 5, plus 1 is 6. 5 times 2, 10. Carry your 1. 5 times 2 is 10, plus 1 is 11. Yep. So how many decimal spots do I have, Jacob? I'm coming back to Jacob. Go ahead. 2. 2. Very good. So you're going to start at the back of this number right here. So I'm going to write it in blue ink and move it in 1, 2 spots. So your answer is, how would I read that? 11,060. Yep. So your comma would go right there. All right, 11,060. Any questions on that? All right, so nothing too exciting. It's the same old multiplication you've been doing for years. It's just now we're throwing in this whole little decimal point thing, all right, where you have to count the number of decimal places you're working with. All right, the next page, we're kind of skipping some of this stuff. We're going to go, whoops. Don't look. It's gone. All right. We are going to calculate the product using partial products. Yeah, we're going to skip that part. Calculate the product. All right, so why don't you go ahead and work on question 1. We'll go over that one, and then the rest I will give you time to work on for homework. All right, so everyone's working on question 1 right now, and I am pausing the video to let all of you YouTube watchers know what's happening. Bye. Here we go. So, most people that I checked had this correct. They put the 400 on the bottom because that will save you some time and you can use this shortcut. Alright, so 4 times 2 is 8. 4 times 5 is 20, carry your 2. 4 times 4 is 16, plus 2 is 18. How many spots in are we going to go? 1. Alright, just 1 spot in. Oh, I think some people were in 2 spots. Is that what happened on yours? Yep, okay. So, question, please. Never mind? Are you sure? Alright, so the class is going to get the rest of the time to finish these next few examples. And, yeah. I will not see you guys on YouTube tomorrow, but I will be back on Thursday. Thank you for watching. Please don't forget to like and subscribe in all of my cringy glory. Alright, have a good day.